and be happy always. Once again, welcome to Shachi's Academy, and today we will discuss the law of variable proportions. That is understood to be the most difficult law. But today we will make it very easy and we will understand the basic concepts, and then we will discuss the law and make the diagram as well. And understand what are the causes of increasing terms and diminishing returns. So let's start with the law. So the law of variable proportions, as the name suggests, here we can see variable. Variable comes from the word vary, that means change. Things which can be changed are known as variable. So this law operates basically in the short run when production of any firm can be increased only by increasing the variable inputs. What are the variable inputs? Just like labor and raw material. Here we are considering a production function where we are using only two factors of production, that is labor and capital. We have discussed in our previous video. If you don't understand the basic concepts, you won't be able to understand the whole law. So first watch that video if you like, and if you know, then it's okay. So variable factors are the factors which can be changed easily in short run, but fixed factors are the factors which need lot of investment, like plant and machinery, which are expensive and cannot be purchased every day, and which are not required to be purchased every day, because once we purchase any machine, we can use it for 10 or 20 years at length. So we need not purchase every day we do production. So fixed factors are fixed and they have to be purchased even producing a single commodity. So that's like machine. Okay. For example, we have a baking plant, we manufacture bread and buns and other pastries, etc. So we have a machine in our bakery plant, and its maximum capacity is suppose 300 buns in one bake, and it requires 6 people for its full utilization. Okay. So this single machine needs 6 people to operate on this. So this is a fixed factor. Okay. And the labor who work on this machine are known as variable factors, right? So variable and fixed factors we have understood, and before understanding this law and reading this out, we need to understand what is fixed proportion and what is variable proportion, because we need to understand variable proportions, right? So here, see, in short run variable proportions operate, and in long run your fixed proportions operate, as we have discussed in our previous video also. What is variable proportion? Take for example, initially there is a single machine, this is single machine. Here we have taken the ratio labor by capital, that is a proportion formula. So labor by capital is here, we have to take out the ratio, so capital is 1. That means we have only single machine in our baking plant, in our bakery, and here we are using 2 laborers. Initially we have only 2 laborers, that means 2 people working on that, 2 workers. Okay, so 2 by 1 is the ratio. Then if we want to increase the production, then what we will do? We will employ more workers or more labor. So we have 3 labor and 1 machine, that is 1 fixed factor. Then if we want to further increase our production, we will use 4 laborers and on 1 machine, then 5 laborers on 1 machine and 6 laborers on 1 machine. Are they equal? No, they all are different. 2 by 1 is not equal to 3 by 1. 3 by 1 is not equal to 4 by 1 or 5 by 1 or 6 by 1. None of them are equal. So they are variable proportions. That means they keep on changing. The proportion is changing as we want to increase our production. Now, in long run, all the factors become variable. Everything can be changed. So we can have as many machines as we want, and we can employ labor on them and increase our production. So what we will do in fixed proportions, initially there was 1 machine and we were employing 2 laborers on that. Okay. Next, after that, if we want to increase, we can have 2 machines and 4 laborers on that. So here 2 ones are 2 and 2 twos are 4. So ratio is again 2 by 1. It's 2 by 1. It was 2 by 1. And now 4 ones are 4, 4 twos are 8. Again 2 by 1. So all these ratios or proportions are equal. So in fixed proportion, your ratio remains constant or same, and in variable proportion your ratio keeps on changing, your proportion changes. Now we will understand this with the help of a machine, and then we will discuss this law. Okay, then we will read out this, because we need to understand what is the basic underlying concept. We need that. Okay, so suppose we have a single machine. Initially there is only 1 labor. So here we have a table. Here it's serial number. This is TP is total product. AP is average productivity and MP is marginal product. Okay, we have a single labor. One labor is there, and when he starts working on this machine single-handedly, what he is doing? He is giving MP of 20 units or utils, whatever you want to consider. Okay, so 20 is his marginal product of single worker or labor. Now, if there is only one labor, then what will be the total product? Because total product is what? All the MPs, when they are added up, it gives you your TP. That means TP is equal to sigma MP of all the workers. Now, when we employ second labor, what happens? Second labor gives us 30 MP, marginal product. And now we have two labors working, so what will be the TP? TP is equal to MP of first labor and MP1 plus MP2. Right? Second labor. So both are that. So that means 20 plus 30 is equal to 50. These both are added 50. Then 20 plus 30 plus 40. For 3 labors it's 90. Then when we apply fourth labor, we have 20 plus 30 plus 40 plus 30 is equal to 120. In this manner, when we add up the MPs, we are getting TP, that is total product. Right? Then, how do we calculate AP, average productivity? When we divide total production of given number of labors by labors is your AP or average product. How? We can take any number of labors, suppose 4 or 3 or 2, suppose we are taking 2. When 2 laborers are working on this or workers are working on this machine, our total product is what? 50. So what we will do? We will divide 50 by 2. What is the answer? 25. So our average product at 2 laborers is 25. In this manner, then again 90 by 3 is equal to 30, 120 by 4 is equal to 30, and here 140 by your 5 is equal to 28, 150 by 6 is equal to 25. In this manner, we can calculate all of them. So our average productivity is calculated, and to make this table, I will tell you a simple trick. Now we need to understand first of all this. Okay. So initially, we were employing only one labor. It was giving us 20 MP and TP was 20. Again, if we want to increase production, we need more labor. So we employ the second labor and we are getting 30 MP. Total is 50. Now, we'll make more ones. 2 laborers will work really nicely and they will increase the production. Then we want more production, and then again we are employing the third labor. That third labor is also working. He is increasing our productivity and our total production becomes 90. Now, the productivity of third labor is highest over here. Marginal product is highest or not? This is 40. Again, you are not able to see 40 anywhere. So, initially our productive MP is increasing and TP is also increasing, right? Now, if we employ the fourth labor, MP decreases to 30 units. Then again, if we employ the fifth labor, MP decreases to 20 units and 6 for 10. And then when we employ the seventh labor or worker, it becomes 0, and for 8 is minus 10. Right? So right here. Up till sixth labor, okay, where production has been increasing, total product. This is total production. That means maximum number of buns that we are able to manufacture with this single machine with the use of 6 laborers. So maximum capacity or full utilization of this machine is ensured when we employ 6 workers, right? Now, we need to see one thing over here. Now, we will try to understand the law over here. What is happening? Now, read out the law. Law of variable proportions state that as more and more of variable factor is combined, more and more of variable factor, that means we are increasing variable factor. What is variable factor? Labor. We are increasing labor. See, 1, 2, 3, 4, we are increasing labor units. Now, with the fixed factor, what is the fixed factor? This machine is the fixed factor. Fixed factor is machine. What will happen? I have put an arrow to make it more clear. I have divided this definition into 2 parts. What happens when we employ more and more variable factor with 1 unit of fixed factor? Marginal product may initially rise. So initially the marginal product, where is the marginal product? Here. Marginal product may initially rise. Initially it will increase, rise. 20, 30, 40 increase. It is increasing or not? Then. But it will eventually decline. It will eventually, at last it will decline, As we employ more and more labor, it will decline. So we are employing more labor, 4, 5, 6. Now it is declining or not? 30, 20, 10. It has declined to 10 now. And may become 0 or negative. What has happened? When we employed 7th worker, what happened to our production? Became 0. MP became 0 or not? Then we employed the 8th one. Our MP or manual productivity became negative. It became minus 10. Right? So this law is authenticated with this term. You can memorize this law in these terms only, because this is law, this is a statement, and it has to be written in this manner only. Don't change its language, right? Then we come to this table. Initially, for this section, that means up till 3 workers, 1, 2, 3, we call it increasing returns to factor. What is factor over here? Variable factor. So these increasing returns are for this labor, not machine, because this is fixed. Okay, increasing returns to factor. Then now here 4, 5, 6, when you employ these 3 laborers, then decreasing returns to factor. Decreasing returns, that means your MP is decreasing. Then when MP becomes negative, this becomes negative returns to factor. So these stages, increasing, decreasing and negative, depend on your MP. So MP is most important over here, right? Then we come to our diagram. What is that? So I am telling you how to make it this diagram very simply. Just make 3 dots on this TP section. Here we have made x and y axis one section, and second is of MP, marginal product. Okay, so this is for total product, marginal product. Make y axis, x-axis, y axis, x-axis. And for y axis, extend it up till negative coordinate. Okay, so what will happen over here? Here we are making a point. We are taking half the length of this y-axis, and we are, to adjacent to this, we are making this point, number 1. Then this is point of inflection, we can say. Then we will keep a good distance. Here more than half we will take a distance, and then we will draw a point. So this distance is wide. So here distance was smaller, distance is bigger. Then we make a third point. Here distance is smaller, and this distance is also less. Now what will happen? Here first of all we will draw this. Okay. Now increasing returns. For increasing returns, we will draw this section. This is very easy now. So here, this is the point of inflection. Point of inflection. You can read from your book, inflection. Okay. Here, what is happening? Here, your MP is increasing, your TP is increasing, right? And here, from this 4th worker, your marginal product starts declining, and your TP starts, it increases, but it starts increasing at decreasing rate. It is increasing at decreasing rate here. Decreasing returns to factor, so it is increasing at decreasing rate. Now see, this slope is gentle. Gentle or not? The slope is quite gentle. And this was steep. Here the slope was very steep because the distance was less. This distance was less and this was more. So this was just like diagonal shape. And now the distance is more, but here this distance is less. So that's why this slope is gentle. This is just like a hill. Hill with a gentler slope. Now what will happen? Up till this point, your TP increases and it becomes maximum at this point. TP is maximum. You can write maximum over here. Now when TP is maximum, 6 point, it becomes constant, and thereafter when it is maximum and constant, for 7th worker, what is your marginal product? That is 0. At when this becomes 0 for 7th worker, your TP becomes maximum. So you will draw a dashed line. You will join them with a dashed line, and here it is 0. So MP is 0 over here, and at this point of inflection, your MP is highest here. So up till here, you can make a point over here. You can just draw a dashed line downward, and you can just point out anywhere over here, and just you draw a curve, MP curve from here. See, never draw an MP curve from 0, because marginal productivity can never be 0 initially, in initial stages. So what we will do here, we will start drawing this. It is maximum over here, When MP is maximum, your point of inflection is attained. Then thereafter, it starts declining, and at this point where TP is maximum or highest, your MP becomes 0, and so this is your MP. Right, this is very simply made. So diagram will be made in one go. This is very simple diagram, you can make it. And how? Here, up till point of inflection, this is first stage, and between this point of inflection and TP is maximum point of TP, your second stage exists, second stage, and when your TP is maximum and marginal productivity becomes negative or 0, it becomes declining, it starts declining, and this is your third stage. So none of the sensible producers in the world enters this third stage. Why? Because your TP declines, your total production declines, and your marginal product becomes negative or 0. So here, no producer will employ 7th and 8th worker. So these are the 3 stages of production or the returns to a factor. Here it is increasing returns, here it is decreasing returns, and here it is negative returns. These are the third stages. Increasing returns corresponds to this part of the diagram. Decreasing returns corresponds to this stage of diagram, and here negative returns in this portion of diagram. Okay, so it's clear, quite clear, I hope so. And if you have any problem, just send in comments. Okay, then why this occurs, we need to see that. Causes of increasing returns to a factor. See, when you increase the quantity or the number of variable factors, your fuller utilization of fixed factor is ensured. Initially, we know that we had only one labor and he was doing all the chores like making the dough, kneading the dough, or adding all the commodities, or adding all the raw material and making buns, baking them, packaging them and selling them, etc. So there was only one labor. So he was too busy to look after anything, and production was also less. And then second worker came, production increased, then third worker came, production further increased. In this manner, production kept on increasing up till the maximum production was 300 buns, and all the 6 workers were employed on the single machine, because it could be fully utilized only when there were 6 workers to work upon this machine. Now, when 6 workers were employed, it ensured its fuller utilization then. And it ensured increasing returns. Then division of labor and increase in efficiency. When we employ more and more labor, this division of labor. See, when there is single worker, that single worker has to do each and everything in bakery, in baking these buns. But when there are 3, 4 or 5, 6 workers, what happens? That work or the task of making buns is divided among all these 6 workers, and they work more efficiently, and in this manner they lead to better production. There's better coordination between the factors. Here the production happens due to the coordination between the fixed factor and the variable factor. So when you increase the number of variable factor and ensure that fuller utilization of this machine happens, then there is better coordination between the machine and the labor. So machine and labor work in better coordination and lead to better production numbers. Okay, then causes of diminishing returns. Eventually, why diminishing returns happen, we need to discuss that also. Here, fixity of the factors. So number one reason is fixity of the factors. See, we can employ up to 6 workers, but not beyond that. Why? Because after we employ beyond 6 workers, when we employ, so what will happen? Some of the workers will quarrel, they will loiter here and there, they will roam here and there, they won't be working, they will be sitting idle or eating away the buns which are being manufactured. So there's no point in employing workers more than 6 in number. So because fuller utilization is ensured only by 6 workers, beyond that people will just sit idle and disturb others. So fixity of the factor. Then imperfect factor substitutability. That means factors are not the perfect substitutes. See, if we keep on increasing the number of laborers and keep a single machine, so machines can't be substituted with labor altogether, because we need machine also, because production takes place with the coordination of 2 factors of production, that is capital and labor. And if we want to do production only with the help of labor, then that is not a good idea. Okay, so we need machines and labor as well for both of them, and they are not perfect substitutes, so the production eventually declines. Then Poor coordination between the factors. When we keep on increasing the factor, that is variable factor, there happens a poor coordination. There is a mismatch. There is a single machine and if there are 16 workers or 20 workers working on a single machine, then there is a poor coordination and efficiency will decline, your production will decline eventually, and this law operates in this manner. So as we employ more and more labor, that is variable factor with fixed factor, your marginal productivity increases initially, it may increase initially, but eventually it will decline, become zero and become negative as well. So I hope this law is understood by you very clearly, and if you have any problem regarding this understanding or the concept of the table over here, so I forgot to tell you one thing about the table. Here you can make this table very easily. You don't have to memorize it or mug it up. How to do that is, see here, you can see a pattern 2, 3, 4. So here the code is 2, 3, 4, 2, 3, write 2, 3, 4, add 0, 0, 0, 0. So this becomes 20, 30, 40, then 3, 2, 1, 3, 2, 1, 2, 3, 4, 3, 2, 1, and 0 minus 1. That is very simple. You can add 0 minus 1 very easily. Now what to do over here is 20, 30, 40, then 30, 20, 10, and the 0 minus 10. You have made this. Now add them up. For single worker, your MP, AP, and PP all are similar. This may come in MCQs also. Okay, so here when there are 2 workers, 20 plus 30 is equal to 50, PP is equal to 50. Then when there are 3 workers, 20 plus 30 plus 40 is equal to 90. Then plus 30 is equal to 120, plus 20 is equal to 140, plus 10 is equal to 150. Okay, and plus 0 is equal to 150 again, that's constant. And then minus 10 is equal to 140 because we have to subtract eventually. Okay, so here then AP we can calculate easily. Then TP divided by number of labors, that's 1 labor is equal to 20. TP divided by 2, that's 50 divided by 2 is 25, 20 divided by 3 is equal to 30. So in this manner you can make this table. In books, what is happening, 2 types of tables are given for you. One to understand TP, MP and AP, that's average product, marginal product and total product. And one to understand this law. With this table that is made in this video only, you can just understand the whole concept, TP, MP, AP, and plus the law of variable proportion with single table. So you can make this table on your own. Just do it and be happy, be cool to everyone, and just study hard and make the things easy with your understanding. Thank you so much for watching our videos and sharing them and subscribing to us. Thank you so much.